What's up? How you doing? I'm Hamish, but a lot of people call me 25 by TD. Let's get started, man. So now, if you face on my channel, make sure you subscribe right here, okay? Subscribe right here. Follow me on Instagram, all social media. Let's get to the business. Given the set of the data below means these are data. They give you data. 4, 17, 7, 14, 18, whatever you have until 11. What do they want? Let's say draw the box and whisker. So draw box and whisker is easy. So first and foremost, you need to get quartile 1, quartile 2, quartile 3, range, you know what I'm saying, all the data. So let's get started. So now I'm gonna say let's get those quartile. So to get quartile 1, I'll show you how you can get quartile 1. Let's get position of quartile 1. So you get quartile 1, you say 25%. 25% is like 2,500. You know what I'm saying? Because say 25% is like 25%, or you can say 25% top. So get quartile 1. Let me start from here, excuse me. So to draw your box and whisker, so box and whisker look like this face. Let me explain to you so you understand. Okay, this is like box and whisker. So this is the minimum data, means out of all these data, the smallest one is going to be here, which roughly if we check is going to be 4. Okay, and this is going to be the maximum data. What's the maximum data here? Roughly quick is 18, if I'm not mistaken. I think it's 18. And then we're going to have to get quartile 1, quartile 3, and this is a quartile 2, or we call it median, this one here. So now let's get quartile 1, quartile 2, quartile 3, and then after that, we're done. And this is the box and whisker. Box and whisker. Okay, cool. So now let's get quartile 1. So this is how you get quartile 1. Quartile 1, or sometimes you call it 25th percentile. So you take n means total, how many number, you plus 1, that's all. So this time you say quartile 1 equal to 2,500 means it's like 1 over 4. It's like say 25 over 100, which is 1 over 4. And then n means how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, and then you plus 1. So this is going to give you the position of the quartile, and I'll show you how to get quartile. So now this is going to be 13 divided by 4. 13 divided by 4, I think it's going to be 3 point something. Take my calculator here just to make sure. Okay, so this 13 over 4. So 13 divided by 4, 3.25. So 3.25. So quartile 1 into the position of 3.25. So you come at your number. So the first mistake that I have, it's not a mistake. I need to rearrange this data. You know what I'm saying? Before you start anything, make sure you rearrange all your data. So I'm going to erase this so that I have to, I can write down here. Okay, what is my data? My data equal to, okay, let me start. I can read right here. The data equal to 4. Okay, 4, and then we have another 4. We have another 4. So 4, and then 4, and then 4. Okay, so all the 4 are gone. Now we go. What is the next one? Oh, no, I made a mistake. 3. So this should be 3 here. So it should be 3 here. Okay, so 3 also is gone. Now we go. Now, what is the next data here? Okay. 3, 4, 4, 10, 4, 18. So I think 10 should be the next one. So 10 is going to be the next one. So 10. Okay, now after 10, now we see what is the next one. 11. No, I made a mistake. 7. I see the 7 here. 7. And then 10. So the 7 is gone. And then 10 is good. It's always good to cancel, so you don't have to go repeat it. 7, 10, and then 7, 10. Okay. 11. I think the next one is 11. So this 11, if you're in exam, cancel this. So 11 next. Okay. Then after 11, now we go 10, 11, 12. I think 12. So 12. Okay. Next one. 12, 14. Okay. 14. Okay. 14 is gone. Okay, now we just go after 14. This is 16 and the 17. Okay, so we got 16 and 17. Yeah, I think we finished 17 and 16. I think all of them, and 18, the last one, 18. Okay, cool. So we have all the data arranged in ascending order. So after that, you say, okay, cool. So after the ascending order, so we say quartile 1 in the position of 3.25. Now we go. This is 1, 2, 3. So 3.25 is more closer. Look, 1, 2, 3. 3.25 is like a position. So 3.25 is if I had approximate this like a 3. So means quartile 1 is this number, which in the position 3, which is 4. You know what I'm saying? Because you say 3, this is a position of quartile. 3.25 means, come here and read, okay, position 1, 2, 3. But if you approximate, this is like 3. Because this number here is not more than 5. If it's a 3.6, then it's going to approximate to be 4 because it's more than a half. So if this number is more than a half, then it's going to become 4. But it's less than a half. 3.2 is less than a half. That's what trick is it? 3. So we'll say, okay, so 1, 2, 3. Oh, so quartile 1 equal to 4. So quartile 1 equal to 4. Okay, so I'll just say quartile 1 equal to 4. So right here, quartile 1 equal to 4. So I don't need all this other stuff. I'll say quartile 1 equal to 4. Quartile 1 equal to 4. So position of quartile is this, but the value of quartile 1 equal to 4. You know what I'm saying? So I can write here, say my quartile 1. Let me write here, quartile 1. So quartile 1 equal to 4. Now we go for quartile 2. So quartile 2 is going to be 50 percentile. So it's going to be 50 percentile quartile 2. So this is saying 50 percentile. So say 50 percentile, 50 percentile. So it's 50 percentile, or another way, n plus 1. Okay, and this is quartile 2 now, or you call it median sometimes. This is a median. Okay, 50 percentile is 1 over 2, meaning, okay, this is going to be 12, 12 plus 1 equals 13. And this is going to be 6.5. So 6.5, now we go, oh, 6.5, now we go. Okay. 1, 2, 3, 4, 5, 6, 7. So 6.5 is the center. So are we going to take 7? Are we going to take 6? Since it is at the center, at the middle of 6, the middle of 1, 2, 3, 4, 5, 6, and 7 means 6.5 is here at the center. So take this 2 divided by 2. Oh, okay. So now this is a position of the quartile is 6.5. But if it means this is a position pose. But for the quartile itself, quartile 2, or we call it median sometime. Are you going to get it? Add these two, we say 10 plus 11 over 2. And this is going to give us 10.5. Oh, so quartile 2 equal to 10.5. Okay, let me write this stuff here. Quartile 2 equal to 10.5. We go fast now. Quartile 2 equal to 10.5. Now we go for quartile 3. So quartile 3, now it's going to be 75 percentile quartile 3. So quartile 3, 75 percentile. So quartile 2, sometimes we call it median. So this is a median here. Know what I'm saying? That's a median. Median. So now that we can say this is median. Oh, median. Quartile 2, we can call it median. Okay, quartile 3. So quartile 3, let's start with the position. Positional quartile 3. How we get it? In other we can say 75 percentile. And they say n plus 1. Okay. So now this MSA, you need to be very, very speedy in exam. So this MSA, 75 of 100 is like, this MSA 75 of 100, which is 3 over 4. If you simplify 3 over 4, n plus 1, what is the n? N is 12 for this case, plus 1, because how then the 12 plus 1? 13. So this 3 over 4, if you simplify by 25, you get 3, by 25, you get 4, 3 over 4, and this will be 13. So take a calculator, okay? Say fraction, and they get 3. I like this calculator, man. Casual. Okay. Fraction 3 over 4. Now come here and say this is 13. Okay. 13. Plug in calculator, and you're gonna get 9.75. So position of quartile is gonna be at 9.75. 9.75. But 9.75 is almost 10. It's almost 10. So I'm gonna come here. 9.75. Now go 1, 2, 3, 4, 5, 6, 7, 8, 9. Means I'll take this because 7.5. I'll take that. Next one. You know what I'm saying? So, excuse me. So my quartile 3. Okay. So what is a quartile 3? Our quartile 3. We say excuse me. Say 9.75, right? 9.75. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 9.75 means is closer to this. Close to 16. You know what I'm saying? It's very close to 16. So, let me just check more if you don't mind. Okay. 3 over 5, 3 over 5, 3 over 4, excuse me. And then times, I would say 12 plus 1 is 13. 13. Okay, 9.75. So 9.75 means it's close to 10. So it means this one is 16. So, wow, quartile 3, because this is a position of quartile 3. So quartile 3 itself equal to this means position number 10, which equal to 10, quartile 3. Okay, cool. So quartile 3 equal to 10. Done. Now what does I want? Let's say draw box and whisker. It's easy. So let's draw box and whisker. So we say box and whisker, we come here. Okay, so now before I draw further, now this is going to be my quartile 1. And what is a quartile 1? Let's say quartile 1 equals 4. 4. Quartile 3. So when you draw, start with the 1 and 3. So don't start with the middle one. Quartile 3. What is a quartile 3 equal to? 10. So then after that, try to look the median. Median is 10.5. Quartile 3. Did I get quartile 3 equal to 10? Oh, come on. How can I? 16, man. Come on. What am I doing? 16. Excuse me. 16. This is a position. It's 10. But is means in the position 10 is 16. 16. So this must be 16. My apologies. 16. So now you go to quartile 2, which is median, which is 10. Now is 10 close from 10 to 4 and 10 to 16. We want to see how the distribution. Okay. From this is 10 to 4 and 10 to 16. This is 6 and this is 6. Oh, so it must be at the middle. Because the length is 6 and the length is 6. So it's like center. So quartile 2. But if let's say this was oh no, excuse me. This is quartile 1. No, it's fine. If somebody let's say quartile 1, let's say quartile 1 equal to, let's assume quartile 1 equals equal to 3, let's say to 2. And quartile 3 equals 16. So how would that be? So I would say if the quartile 2 equal to 10.5, so I know for effects here is going to be 5.5, but here is going to be 7.5. So if I draw means it's more closer to the right. So it's more distributed to the left, like it's more distributed to the left. Means it's distributed to the left, means the left there is more length compared to the right. You know what I'm saying? So even here, this is 5.5 because if this is quartile 2, 10.5, so it's going to be a slighter like this. So we say it's distributed to the left because you know why? There's more space to the left. So now you go from 16 to the bigger number. What is the highest number? 18. Means you have a 2 unit here. 20 this maximum value. Now we go from 4 to 3. It's just only 1 unit. So here I can just put a little longer because it's 2 unit. Let me do like this. Let me say this is 2 unit. 218. This is just 1 unit. 2, 3. Okay, so this is box and whisker. You know what I'm saying? This is how you draw box and whisker. And that's how you get it. So this is maximum value, whatever you have. So sometimes they're not gonna only ask that. They're gonna ask, okay, what is range? So how you get range? Range means you take maximum minus minimum. So that's not part of the question, but I'm just doing show you because you know sometimes they ask all those stuff. You know what I'm saying? Let me just ask. Okay, let's get a range. So sometimes they ask, okay, what is range? Oh, what is quartile 1? So we know how to get quartile 1. Now let's get range and interquartile range. Okay, let's start with the range. So how we get range? Range we take maximum value minus minimum value. Maximum minus minimum. Range you get maximum minus minimum. So for this case, what is the maximum? Maximum equal to 18 minus minimum equal to 3 equal to 15. Okay, now. It's not part of the question, but I'm explain to you so you can get the hang of what is happening. Now, okay, let's say they find interquartile range. Interquartile range. Oh, so these are range, mean the range but of quartile. Take upper quartile minus lower quartile. Means upper minus lower. And this interquartile range is going to be 16 minus 4. 16 minus 4 equal to 12 interquartile range. Now let's go to the next one. Let's say this asks for maximum value. So we know maximum value. What is maximum value equal to 18? Minimum value equal to 4. Minimum value equal to 3. Excuse me, 3. Now what age do they ask sometimes? I think that's all. Okay, so the first question is done. So now we want to go for the second number 2. Question number 2, they say, okay, let me just make a space here quick. And there we go. Okay, this is a big equation. Second one. but the approach is almost the same. Okay, so with the space here also, we don't need this. Okay, cool, let's go. Okay, let's go. Now the equation say here, okay, suppose the company okay, cool. Now let's go for the next question. So next question they say, suppose a company has 10 employees. Oh, so they employ 10 people, right? Okay. We see. So one earning $1,600, $1. In the second one, another one also earning that one. Two earning this amount, one earning that amount, and five earning this. So what do they want? Find the mean. Easy. So we know how to get mean. To get mean, which is represented by this letter, I think I can do it on top. So we send space. I can do right here. Mean, we say means you find mean or average is the same thing. Sum all the stuff. So we say our data. Okay, so what is our data? It starts from 1, means there are 10 of them, let's say 10 employees. To 10, start from 1 to 10 of xi. So what is xi meaning? Let me explain to you that means so you can understand the thing. Okay. I'm going to draw a table here. Okay, let's draw a table. Okay. So when I draw a table, let's draw a table here. Man, okay. The color quick. Okay, let's draw a table here. The 10 of them, huh? So the data, you call them, these you call them I, and these are X, I always. Means the face data. What is the face data? Let's say face employee get done of 1,006. So 1,000. Okay, cool. That's the face one. The second one, and one any. Okay, 1, 2, 1, 2, 3, 1, 2, 3, 4. See? So make sure you feel the correct data that I took. You know, I don't want to make no mistake here. Excuse me just a second. Okay, 1, 2, the second one. Okay, even this also, more 0. So here should be another 0 here. Okay, cool. The second one, get this on the third one. 2 earning means there are 2 of them. Means one is earning 1, 2, 3, 4, and another one also gaining 1, 2, 3, 4. Now, one earning, okay, there's another one, which is number 5 earning 1, 2, 3, 4. Now, the last one, 5, 1, the end this. So, there's 6, 7, 8, 9, 10. So, each one is going to be ending by 3, 2, 1, 2, 3. 3, 2, 1, 2, 3, 3, 2, 1, 2, 3, 3, 2, 1, 2, 3 dollars. So now we do the 1. So this, when you say this means sum of all the xi, I is like a number. It starts from 1 to, for this case, it's up to 10. To 10. But if the 12, you say here 12 means starting and finish. You sum means you add all these x's, add all of them. That's what you say sum. So what does that mean? This time you say add x1, x2 means like x1 plus x2 means instead of say I, you say 1, 2, 3 all the way to, you add 2x, 10. And then after that, you divide by total. Divide by n. So here you can just divide by n, means the total of this number. You know what I'm saying? So that's how you get your mean, or sometimes they call it average, you know? Okay, now let's get it. So say find the mean. Okay. So I'm going to say, oh, let's get my mean now. So the mean equal, okay, x1. What is x1? 1, 6. So we see all of the, okay, 1, 6, 1, 2, 3, 4, plus 1, 2, 1, 2, 3. Oh, even the second, I think it has a 4 0. So this must be another 0. 1 2 3 4 plus. But I think someone made a mistake somewhere there, but I try to follow the steps. I believe if you follow the step correct, then you should get the right answer, you know what I'm saying? But I think I made some mistake somewhere, they want to plus minus, so I don't want to waste a lot of time. I know you can do this, I know you can do this, you know what I'm saying? 32, 1, 2, 3, minus mean. What does that mean? Mean equals 6,000. 1, 2, 3, 4. But remember there are 5 of them. So I can just say, let me just say this. 5 of whatever I'm going to get here, but I must have it squared. You know what I'm saying? Because I'm going to have to say 32 minus mean and then square. But how many of them there? 5. I mean, this process must go 5 times. So I want to say a space that's a seed. So we add, okay, now we go for this one. 4,000. So I'm going to do the same thing. 4,000, 1, 2, 3, 4, 40,000, excuse me, minus our mean. Each data must minus mean. 2, 3, 4. Okay, now we come this one. There's 60, there are 2 of them. But remember, if I take xi, which is 60, minus that 60 square is going to be 0, so I don't have to write. Even this is going to be 60, which is xi, minus mean, because we must minus the mean, and the square. This is going to be the same number, but the same number, 0 square, so I don't have to write. Now I'll go for the last one. For the last one, last one, have 120, 1, 2, 3, minus 1 more 0, square, and then now we go for 160. Okay, now minus by 1, 2, 3, 4. Okay, so variance equal 10 minus 1 equal to 9, and then you plug this in the calculator. If you plug this in the calculator, it's gonna give us, okay, take everything, plug all of this, you're gonna get 40, like divide everything, take these all, put in the calculator, divide, you're gonna get 41,596.8127. So this is going to be our variance. Excuse me, sorry. Oh, we can just go. Let me go step by step. Let me go step by step so you can see. Okay, excuse me, shifting. Okay, let's go step by step. So now we go say, okay, let's ask for the first one. No, this is not going to be correct. Okay, step by step. Okay, now we go. Just a minute. Okay. Okay. So if you add all this stuff here. All this stuff when you add is going to give you 199. Take all these, divide by 9. Know what I'm saying? When you divide by 9, it's going to give you 1991111. How many? 3, 4. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You know what I'm saying? So this is going to be our variance. So now, if you want to get standard deviation, we say standard deviation, how are we going to get? You have to square root the variance, which is 1991, 2, 3, 4, 5, 6, 7. Okay, cool. And then you square root the answer. Now let's go square root the answer. And this is going to give us 44621 8.86808. So these are standard deviation. You know what I'm saying? Standard deviation. 44621.87. And if you approximate, this is going to be 87. So 44621.87. These are standard deviation. So we're done with the standard deviation. Now we want to go quartile deviation. So quartile deviation means you have to get a quartiles. So I don't need these. Let me make a space. So you have to get a quartile. Because we talk about quartile deviation, it means you need to know the quartile, quartile 1, quartile 2, quartile 3, etc., etc. So before we do that, I can just show you how to get box and whisker. But since the one quartile deviation, let me not waste a lot of time doing box and whisker. Let's just get quartile deviation alone, what it asks us for. But it's very, very important for you to understand what is happening. Okay. Okay, so now there are 10 terms. So since there are 10 terms, I'm going to say, okay, quartile 1, position of quartile 1, how we get it? Quartile 1 is like 25 percentile. So it's like 25 percentile, which is 25 percentile, say n plus 1. It give you position of quartile. So let's say 1 over 4, because 25 over 100 is 1 over 4, and then n. What is the n? 10. 10 plus, because n equal 10, 10 plus 1 equal to 11. And this is going to give us 11 divided by 4 equal to 11 divided by 4. 11 divided by 4. 11 divided by 4, you get, excuse me, shifting. 11 shifting. Clear. Let me clear my calculator just a minute. 11 divided by 4. Okay, 2.75. So this is going to give us 2.75. So 2.75 is the position of quartile 1. So if you want to get quartile 1, you come here now. Look, 2.75. Look, this is 1, 2. 2.75 is almost close to 3. So this is going to be my quartile 1. Oh, my quartile 1, this number here, because 2.7, when you approximate, equal to 3. So quartile 1, this is the position of quartile 1. So quartile 1 actual result 1, 2, 3. Now we want to go for position of quartile 2. Quartile 2 means median, which we had it already. What is our median? Median equals 360. 1, 2, 3. Okay. Now we go for quartile position of quartile 2. Or if you want to calculate it, you can just calculate it like I say. We say quartile 2, 50%, 50 percentile, n plus 1, and this equal to 1 over 2, because 50% is like 50 over 100, 1 over 2, and then n is 10, 10 plus 1 equal to 11. This is 5.5. 5.5 is here. Look, 1, 2, 3, 4, 5. 5.5 is somewhere here. So in the middle of these two numbers. That's why we have to add this, divide by 2, which is going to give us this number here, 36. Add these two. So we add the middle 2. So now median, which we had it already, quartile 2, equal to 32. 1, 2, 3 plus 5. 1, 2, 3 equals 72. 1, 2 divided by 2. Divided by 2. 36. It's going to give us that one. Okay. Now this is this 36,000, which we did already. Quartile 3. So let's start with the position. Position of quartile 3. Okay, we say 75 percentile. Say n plus 1. So 75% is like 75 over 100. 75 over 100. And this one you divide by 25, 3 by 25 equals 4. So 3 over 4. So 3 over 4. Okay, 11, because 10 plus 1 is 11. Okay, so now take a calculator, 3 over 4. So 3 over 4, 3 over 4. And then come here, plug your number, which equal to 11. Okay, 8.25, 8.25. So position of quartile 3 equal to 8.25, 8.25. So 8.25, look, is somewhere here, but it's not even half. So I'd rather take this, because if you approximate this, is closer to 8 than 9. So I'd rather take what? This. This is my quartile 3. 60,000. So quartile 3. Quartile 3. 1, 2, 3. So now that's not a question. The question is say find the quartile deviation. Quartile deviation always you take quartile 3 minus quartile 1, and then you divide by 2. That's a quartile deviation. So quartile deviation. Okay. So this is our quartile 3. And this is quartile 1, take this minus that, divide by 2. So quartile deviation for this one here, we're going to say quartile 3 minus quartile 1 over 2. What is a quartile 3? 6,000. This is not enough, so I'll just erase here, please you understand what is happening. So I'll just erase, make space, you know what I'm saying? Because I got all this in me. Okay, cool. So now let's get our quartile deviation equal to quartile 3. Quartile 3 we got, which is 60,000. 1, 2, 3, 4 minus quartile 1 equals 32. I think so. I believe so. 1, 2, 3, and then we divide by 2. And now 0, this 0 minus 0 equals 2. 1, 2. We got 3 of them. and this is going to be equal to 2080 divided by 2. So this is going to be equal to 14, 1, 2, 3. So this is quartile deviation. So we got quartile deviation. Now we want to go for range. Range meaning take the upper data. Okay, so now we have all the quartiles. You know what I'm saying? Let me write all the quartiles. Okay, so quartile 1, I have it. Okay, so this is quartile deviation 14300. Quartile deviation. Quartile deviation, we got it. So quartile 1 we have, quartile 2 we have, which is this one median, and quartile 3 we have. Let me write them because I want to do something. I want to draw box and whisker. Okay, before we go, let's say find the interquartile range. Interquartile range, take quartile 3 minus quartile 1. Interquartile range, interquartile range, interquartile range. So quartile 3 minus quartile 1. What is a quartile 3? Which we did, okay. 6,000, 1, 2, 3, 4. Okay, minus quartile 1, what is quartile 1? 3, 2, 1, 2, 3. Yeah, 2080, 1, 2, 3. So this is quartile range. Now, I just want you to find normal range. Normal range always take a bigger data minus smaller data. So take this minus that. So normal range means it's a range equal to 1, 6, 1, 2, 3. And then minus 32, 1, 2, 3. Okay, so now 3, 0, 3, 0. So 1, 2, 3. Okay, 60 minus 32, 2080. And then 1. So this is a range. Like take bigger data, biggest minus smaller means maximum data. This is a maximum data. Take the most maximum one, the maximum one, minus the minimum. That's it. It's going to give us a range. Now let's draw box and whisker. It's not part of the question, but let's just draw it for fun. So that you get to understand. Box and whisker also we can draw it. I'm saying? Okay, cool. So box and whisker you can draw. So we know we're done with statistics, huh? Okay, cool. Now let's draw box and whisker. So box and whisker always start with that box here. That box and whisker. This is quartile 1, quartile 3, and now start with those ones. Quartile 1 equal to 32, 1, 2, 3. Quartile 3 equal to 60, 1, 2, 3. Now, you're going to have to think now, what is quartile 2, my median? My median equal to 36,000. So now I'm going to come here, 36,000 close to this or close to 6,000? I think it's more closer to this, somewhere here. You know what I'm saying? It's more close to quartile 1. So say this is going to be my quartile 2, which is 36, 1, 2, 3. You know what I'm saying? So these data are distributed to the right because there's a bigger space here. So sometimes they ask that question, is the data distributed to the left or distributed to the right? It's more distributed to the right because you see there's a bigger space here from quartile 2 to 3. So now you go. So now you come here from 60,000. What is the upper value? The upper value is 160. So here to 160 and from 32,000, no, that's the last data because we don't have no more less data than this. Means that's where we stop. We cannot even move to the left. You know what I'm saying? If it was 30,000, I was going to move some few steps. I mean, this is a minimum also. So this box and whisker is going to start from right here, this point, but here is going to go more to the bigger value, means maximum value 160,000. 160, 1, 2, 3. Yeah, 160,000. So that's how you're going to draw this box and whisker. And the question sometimes they ask this distribution of the data. So data is more distributed to the right. Can you see? Means all the spaces to the right. Data distributed to the right. Data distributed to the right. Distributed to the right. Distributed to the right. Or sometimes you can say it's positive skew because it's positive. So you can say positive skew. The data is more of the positive skew. Skew, no man. Data distributed or positive skew. So yeah, that's how you do this question, man. So if you're first time on my channel, make sure you subscribe, share this video to a lot of people, and click the subscription button. Follow me on Instagram and all the social media. You know what I mean? Thank you a lot for your time. Peace, and I'm out. Thank you.